Hey everyone, in this lesson we're looking at linear equations and graphs. This one, there's a bit of material to cover here, so just hang tight with me. And there's a few things that we can't really fully delve into until the next lesson, or the next video. So we're gonna just kind of take a cursory view at a lot of these things, and then go much deeper into the next video. But let's just kind of start with this. When we talk about equations and graphs, what we were talking about are the two fundamental realms of math. And many people don't often think about this, but for so often in our lives, when we think of math, we think of just the numbers. We think of like 2x plus 7, or we think of I have 2 apples and 7 apples together to make 9 apples. We use all of this sort of thing. And that's one, but that's only really one realm of math. It's the realm of equations and the realm of numbers. The numbers interact and intersect, and they do these really cool combinations. They find these things called solutions, which are like just the just all the things that make an equation true. And it's this really beautiful chemistry that goes on in there. And at least I think it's pretty cool. And then we go into something else, and we go to this other realm that's not often talked about, and can really trip us up if we're not careful. It's this entirely new realm of math called graphs. But not in some ways, it's not really a new realm at all. In some ways, it's the exact same realm we've been dealing with. It's just like we're looking at it through different eyes. We are almost in some ways putting on a different pair of sunglasses that's showing a whole different set of colors of the world of math. And so it looks very, very different. Whereas the realm of equations is just numbers and computations and answers and figures and all that sort of stuff. The realm of graphs is lines and points and images and visuals. It's doing the exact same things and does all the exact same things as an equation, but it just looks really, really differently. When I add numbers in a graph, it looks really different. It changes the way the graph looks. When I when I when you multiply both sides of the graph by equation by number, it does something. Well, it actually does nothing to the graph. So because what you do is you're making this equation the same on both sides. But the point is, the the realm of equations, realms of graphs are intricately interwoven. In some ways, it's really the same world, it's the same thing, except just viewed in a different way and a different look. In some ways, some people say the realm of graphs looks a lot prettier. It looks, you can actually see it. So what we're going to look at is how these two realms interact, and how to understand different parts of the realms, or the ways of viewing these two different realms. Okay, which are actually, again, the same thing, just looked a different way. To really get a definition of what the difference between the two realms are, a graph, the realm of graphs is just the plot of all the solutions of an equation. So to give an example of what that looks like, we've got a graph down here. And I'm really sorry that I can't show you the grid lines in this video. It looks like the grid lines probably won't show up. And I don't know why that is. Well, actually, I kind of know why that is, but I can't really do anything about it. But if you do go to the OneNote video, the OneNote will show you exactly what it looks like. It'll show you all the grid lines and everything. It'll look beautiful. So if I've got this line here, this line is not really a line at all. What it is a bunch of points. There's a point here, there's a point here, there's a point here, there's a point here. It's a bunch of points that are all together. And all these points put together make what looks like a line. But keep in mind, be very careful. Don't be fooled. This isn't a line. This is a bunch of points. It's just a giant mass of a ton of points put together that are so close together, they all look like they're a line, but it's not a line. Lines in the realm of graphs are an illusion. They're false. They don't exist. They're not in existence. What's going on here is just a bunch of points put together. What are these points? These points specifically are solutions to the equation, a certain equation. In fact, it's solutions to this equation right here, written in computer form on the left and written in something that's more understandable on the right. Y equals negative 2 over 5 over 3, or sorry, 2.5 divided by 3.5 times x plus 2.5. Okay, what does this mean? Well, what this means is if I take this point right here, let's say here's a sample point. What is this? This looks like it's the value. If I do my little battleship here, we've got what value is this for x? Well, we've got on the x-axis, we haven't moved left or right at all. We're at 0, so that's 0 on the x-axis. And on the y-axis, we've got, let's see, that's 1, 2, it's about 2.5. So that's about 0, 2.5. Okay, so this is the point, this is the x value of 0 and the y value of 2.5. In other words, x equals 0, or it makes it very clear, x equals 0 and y equals 2.5. That's what we're saying. That's what this point is saying. It's not just a dot even, it's communicating information. It is telling us the value of x right now is 0 and the value of y is 2.5. What does that mean? Well, here's what that means. That means if I plug that value, if I plug in, it's telling me, if I plug in 0 for x and I plug in y, is a 2.5 for y in the equation, I'll get a true statement. Let's see what this looks like. So if I plug in 0 for x, let's put in the rest of the stuff. So x is 0, and I plug in 2.5 for y, so y is 2.5, and I fill in the rest of that information here. So we've got negative 2.5 over 3.5. Let's see, there's that times, and we got plus 2.5. We put all the rest of it in, it should work out. So let's see what happens. This should be a true statement. A solution is just a true statement where both sides are equal. Let's look at this. Negative 2.5 divided by 3.5 times 0. Well, that's just 0. That's simple enough. 0. And then plus 2.5, that's plus 2.5. 2.5 equals 0 plus 2.5. All right, so we work down one more step. 2.5 equals, let's see, 0 plus 2.5, that's 2.5. Oh, great. 2.5 equals 2.5. If I get something that's where it's the same thing on both sides, I have found a solution. I've made something that's true and that's good, and that's the point of math, to find what's true and to find what's good. Okay, so we've got, that's what this is saying. And I could do this at any point. I could say, this point over here, this looks like the value, what is that? It looks like 1.5, 1.5. If I was to plug that into the equation, I would get something true again. Maybe it'd be 3 equals 3, or 1.5 equals 1.5. I don't know. But that becomes a true statement. Over here, I've got, let's see, this point over here, I've got let's see, it's the x value is, let's see, 1, 2, 3.5. And the y value is, well, it doesn't go up or down at all. The y value is 0. So we've got 3.5, 0. That is the value of the equation. If I plug in 3.5 for x and 0 for y, I would get a true statement. Okay, cool. Let's move on. That's what all this is. This is a bunch of points. Okay, so if I say, let's take that, and now let's talk about this idea of slope. Now, slope, this might be something important for you to write down. Slope is the same thing for our purposes as the rate of change. It means the same thing. You don't got to worry about anything else. That slope means rate of change. And rate of change, and whether you're talking about equations or graphs, we can write that as this really fancy thing called change in y over change in x. Or what I mean by that is the amount that y changes, the amount of y that y changes. If I pick 2 points, if I go down to this graph and I pick 2 points, I'm trying to figure out the amount. Let's say I pick the points, I don't know, let's choose 1.5, 1.5, and 3.50. The slope is the amount that y changes divided by the amount that x changes. And we get a lot more into slope later. I'd love to talk more about it. In this class, we talked about how a slope of 1 how slope of 1 looks something like this, where the change in 1 point is, it's always the rise, the amount we change in y is 1, and the amount we change in x, the amount we change in x is 1. So, and if we do like 2, the slope of 2 would look something like that, and the slope of 3, something like that. It's the steepness of the slope. And we can find that steepness, the slope, by finding the amount that it changes in y, the amount the height changes, the y changes, the height, divided by how far we've gone, the change in x. Okay, so for example, in this point, we would find the change in y, the height change, by saying, okay, we went from 1.5 down to 0. So we went minus 1.5, and we went across, let's see, we went from 1.5 to 3.5. We went, let's see, 1.5 to 3.5. That's the, let's see, let's see, how far is that? That's 3.5 minus 1.5, that's 2, right? Yeah, but that should be 2. 1.5 divided by 2. Okay, great. So that gives us the slope. You notice what I did here in order to figure out, before we move on, to figure out the amount we ran, I subtracted this second point, the 3.5, from the first point, the 1.5. If you subtract the two, you can figure out how far you've gone. And that's exactly what we do in equations. When an equation, it just gives us 2 points. In an equation, when we have defined a slope of something, if you're just given an equation, we do something called y2 minus y1. Oh, that is incorrect. Let's just forget that. Divided by x2 minus x1. You take the second y point, and if you want to find the change in y, you take the second y point and you subtract the first y point. And you find the change in x, you take the second x point and subtract the first x point. So for example, in this one, I took the second x point, the 3.5, and subtracted the first x point, the 1.5. Okay. So that's how we do that. It's a change in y and a change of x. And so in the realm of equations, in the realm of numbers, you're just given 2 points. You can take the 2 y's, you can subtract 1 y from the other y, 1 height from another, and subtract 1 x from another, subtract them from each other. So the change in y and the change of x. A way that this is talked about often in graphs is the idea of rise over run. Rise over run. And that's kind of what we just did here. We kind of figured out, okay, we took this 1.5, and we said, how far did we rise? How much did we change in y? We rose. We didn't actually rise at all. We went down. We fell 1.5. Or in other words, we rose a negative 1.5. How far did we go up? We went up negative 1.5. We went because it went down 1.5. Okay, so that was our rise, was 1.5. And then our run, how far we went, we can count that. That's was 1, 2. We rose at negative 1.5 and we ran 2. Okay. So that's rise over run, and that is change in y over change in x. In the realm of equations, it's y2 minus y1 over x2 minus x1. I know I'm introducing a lot of stuff right here. I'm really covering a lot of material, but just stay with me. This is, I hope for some of you this might just be a review. For others of you, this might be a whole new material. If you'd like more about this, just let me know. I'd love to walk you through this more deeply. Okay, that's slope. That's the basics of what slope is. Now, the x-intercept, in order to understand an x-intercept, that's really a graphy kind of phrase. When we think of interceptions, we're thinking of the way you understand that, the way the best understood is through graphs. It's hard to really understand an x-intercept in an equation. We're going to find a way to get an x-intercept in an equation, but it's really hard. It's really easy to understand it in terms of graph. And to think about it, we think about what an intercept is. Think about an interception in like football, for example. In football, when there's an interception, things are going, they're running smoothly, and all of a sudden when you're trying to pass a ball, it gets interrupted by the other team. It's suddenly the other team just butts in and gets in there and says, "Hey, here I am, and we've got your ball now." So that's really what an x-intercept is. It says the line's going, it's running, it's going down. It's going, it's running down, it's doing its course, and all of a sudden, out of nowhere, just out of absolutely nowhere, this x-intercept Let's use an orange color. This x-axis here just kind of butts in the way. So this graph is going down, it's going down, it's going down, it's going down. And all of a sudden the x-intercept gets in the way. Just boom, there it is. X-intercept, it's just, sorry, the x-axis just intercepts the graph. And so we got to figure out, well, where is this point that's intercepting, that's intersecting what's going on? It's kind of interrupting what's happening. What's that value at what point is it interrupting? And we can see it right here. That's the value 3.50. At the point 3.50, x is interrupting. It's intercepting the line. Okay. So in other words, to put it in the way I've written in this little definition here, is the point where the equation touches the x-axis. This is where that blue line is touching the x-axis. Same thing with y-intercept. It's where the y-intercept gets, the y-axis gets in the way. It just kind of butts in. And you can see that as the graph goes up and up and up, or down, 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 it eventually hits this y-axis. And so the question asks, so where does that happen? It happens at the value 0 at this point right here. This point right here. This point just so happens to be 0, 2.5. That is the point of that interception. So we say the y-intercept is 0, 2.5. Okay, you notice something interesting about this, or if you did enough of these interceptions, these x-intercepts and y-intercepts, you would notice really interestingly that all of the x-intercepts have a y value of 0. And here's why that is. If we look at the x line, this x line right here, this line right here, as far as y is concerned, you can call this the line. This x-axis is the same thing as saying y equals 0 axis. Because if you were to graph the line y equals 0, remember what it's like to graph like a solid line, just a line of x equals something or y equals something. You just plot all the points where that's true. So y equals 0. This is the y equals 0 axis. So if I was to take an equation such as this one, this is our green equation right here. This green equation. This is the one we're looking at right here. If I was to take this and plug in the value of 0 for y, I'd figure out the x-intercept. Okay, here's what this means. So if I wanted to figure out, let's change the colors a little bit. If I want to figure this out, I want to figure out where it intercepts the y equals 0 axis. That's what I'm trying to do. If I'm trying to find the x-intercept, as far as an equation goes, this is what I'm looking at here. If I want to try to find the x-intercepts, I need to plug in y equals 0 and then solve. And then the solution is or the answer is our solution, comma 0. Okay, here's what that means. Let's kind of clean that up a little bit. Okay, maybe I'm a little picky here. So if I have the equation y equals negative 2.5 divided by 3.5 times x plus 2.5, we can find the intersection point by plugging in y equals 0, because we're trying to find the x-intercept, trying to figure out where it intercepts with the y, we're trying to find where it intercepts with the y equals 0 axis. So y equals 0. So we get 0 equals negative 2.5 divided by 3.5 times x plus 2.5. Okay, and we just need to figure out what x is. We know that y equals 0 because that's what this is. We need to figure out what x is. So we'll go ahead and try to solve this as best we can. Let's see, to solve an equation, we subtract 2.5 from both sides, start the thing that's furthest away. Subtract 2.5, that gives us negative 2.5 equals negative 2.5 over 3.5 times x. Okay, multiply both sides by 3.5. Let's see, because we need to get rid of that, or we need to get rid of that negative 2.5 divided by 3.5 because that's what's closest. So what we'll do is we'll multiply both sides by the reciprocal. We will multiply both sides by 3.5 divided by negative 2.5. So multiply this by 3.5 over negative 2.5, multiply that by 3.5 over negative 2.5. All right, cool. Let's see. Oh, that's convenient. So this cancels out. That cancels out. These cancel out. And so we get 3.5 equals x. Neat. So our solution and our answer is, well, the values for x and y. But we know that y equals 0. We were told that from the beginning because we're trying to figure out where it touches the y equals 0 axis, right? So the solution would be 3.5 and 0. That would be our solution, which is interestingly the same thing we found over here for the graph. It's this point, 3.5, 0. When we were trying to graph this, we got 3.5, 0 as well. It's the same thing, just look at it in two different ways. And it's the exact same thing with the y-intercept as well. When we want to find the y-intercept, what we need to do is find the point where the equation touches the y-axis. Now, if you've done enough of these, you notice something interesting as well, that the y-intercept is always 0. The x value of the y-intercept is always 0. In fact, this is the x equals 0 axis. It seems kind of strange, or maybe almost counterintuitive, but at first, but once you start realizing, start graphing, if you were to graph x equals 0, that's a straight up and down vertical line that goes straight up and down. This is the x equals 0 axis. So we know that from the graph that this is the point 0, 2.5. This is the point. Let's see. Let's graph that quickly. 0, 2.5. Let's look at how that looks when we use the equation. In the equation, we have y equals negative 2.5 or 3.5 times x plus 2.5. That's what we're used to. But in this case, we know we're going to figure out where it crosses the x equals 0 axis. So we're going to plug in 0 for x, which gives us, let's see, that'll give us y. Let's put some space in here. So y equals negative 2.5 divided by 3.5 times 0 plus 2.5. We can work this out rather quickly. Negative 2.5 times divided by 3.5 times 0, that is 0 plus 2.5 equals y. Let's see, 0 plus 2.5 is 2.5, and y equals 2.5. Great. So when we need to plot this point, we get the value. We know that x is 0 because we're plotting it on the x equals 0 axis, otherwise known as the y-axis. And the y value is what we just found. We found 2.5 for y. So we'll plot 2.5, which is the exact same thing as we got when we got on the graph. These are the same numbers because, again, the graph and the equations are the same thing, just viewed in two very different ways, very different lenses, two different realms that express the same underlying thing. Like how the spiritual realm and the physical realm kind of like working together, and they kind of do and they interact with the same thing, you know? Okay, cool. So, so if we want to try to find this first problem, it says to find the intercepts of the line, looks like we just did it. The y-intercept is 0, 2.5, and the x-intercept is 3.5, 0. Okay, let's look at some more problems and see if we can get the rest of the problems. It says on this problem, which I need to partition off because I've used a lot of space here for that first problem. There it is. What is the slope of this line? Okay, the slope of this line is, remember what it was, we're looking at a graph. And remember what we said for graphs. We said the slope of a line is a change in y divided by the change in x, otherwise known as the rise divided by the run, the rise over the run. How far we rise, we need to pick 2 points and figure out how far we rise to get that point and how far we run to get to that point, how far we go across to get that point. Let's pick 2 points. Let's see, let's check this point right here. Let's see, that's 1, 2, 3, 4. That's about 5. And then the height is 2. And let's say another point. Let's say that's the point up here. Let's see, that's also 5. Let's see, because I went 5 to the right. And I went, let's see, but we go 6 up to get to that one. Okay, let's see the rise and the run of these 2 points. Let's see. So the rise over the run. The rise of these 2 points, how far I have to rise to get from, let's say, from the bottom point to the top point. Let's say from this distance, let's say this is 0.1, this is 0.2. The amount I rise to get that first point, from one point to the next point, I rise 4 to do that. And I run, how far do I go left and right to get to that point? Well, actually, I don't go anywhere. I stay at 5 the entire time. I'm at 5. So I've run 0. So that means that we run our slope, which is our rise over our run, which is also the rate of change as well, is 4 divided by 0. Okay. What is that? Is that 0? Is that 4? Is that undefined? That's actually undefined. There's no way to define it. It's like saying I've got 4 pieces of pizza and I needed to divide it evenly among 0 people. How many pieces does each person get? Well, I don't know. How do you give 4 pieces of pizza to 0 people and evenly? You can't ever get rid of your 4 pieces of pizza. So this is undefined. This is the slope of the line is undefined. So we'll go ahead and fill that in. A quick test, if you want to see it visually, any vertical line is going to do the same thing. It's always going to be undefined because it's like it's like an infinite slope almost. It's like you go up infinitely before you move at all. Okay, so but to put that in a different way, just to clear things up, infinity is not the same thing as undefined. They're 2 very different things. Even if you were to go up infinity, you would still never go across 1 because you never get to 5. You never get to 6. Your x value never moves. It just stays at 5 forever. So the slope is not even infinity. It's just we can't even figure it out. Okay, that's that problem. Next problem, what is the slope of the line that contains these points? All right. So we've got these points. Let's see. This is in the realm. We're moving outside of the realm of graphs now, and now we're trying to find the realm. We're trying to do this in the realm of numbers, in the realm of equations. Okay, let's see. Remember what we had for that realm. We know that an easy way to see that is y2 minus y1 over x2 minus x1. We need to find the amount that we change in y and subtract and divide that by the amount we change in x. The change in y over the change in x, which is what that is. Okay, so let's pick 2 of these. Let's see. Each of these. One of the great things about a table like this is that each little box is its own point. So this is the point 53, 0. This is the point, let's see, negative 5, 57. And this is the point 10, 45, 10. Excuse me, 45, 10. And this is the point, let's see, that'd be the point 5, 49. All right. We can pick any point we'd like to and just work with it. Let's say we pick the points, for example. I don't know. Let's try this point right here. Let's say this is point number 1. You're now point number 1, and you are now point number 2, Mr. 53, 0. Okay. So we need to figure out how far we change in y, and divide that by how much we change in x to get from one place to the next. Okay. So we could think about it of how far we change. We go from in y. We go from, ooh, did I write that wrong? Yeah, I wrote that wrong. This is, excuse me, I apologize. This is 49, 49, 5. There it is. And this would be 57, 5. Sorry about that. This would be 57, negative 5. Okay, so we need to figure out the change that we do from 5 to 0. And we could say, well, it's a change. If we start at the height of 5 and we go down to 0, that means we've lost 5. We've got a negative 5. And so we're going to get negative 5. An easy way to think about this, if we plug into our equation, we get y2 minus y1 over x2 minus x1. We'd have 5. We'd have 0 let's see, this is x2, y2. This is the x of 0.2 and the y of 0.2. No, down here we've got the x of 0.1 and the y of 0.1. So if we're just literally just plug into our equation, we get 0 minus 5. So y2 is 0 and y1 is 5. And so you can think about it. So if I start at 5 and I go down to 0, I've lost 5. So the top portion is going to be negative 5. And for 2, we start at 49 and we move over to 53. So we're going to do 53 minus 49. You can think about it. If I go from 49 to 53, I'm moving over. That has 4 spaces. Same thing over here. If I do 53 minus 49, that is 4. So our answer is negative 5 over 4. And that's what we're looking for. So our slope is negative 5 over 4. And that's our answer. All right, let's do one more. And this one's a tougher one. This is a word problem. And we don't like word problems usually, but maybe we can work this one out. Maybe we can figure out what kind of dissect what's going on here. It says Manco went scuba diving. As he dove deeper, the water pressure around him increased at a constant rate. This table compares Manco's depth in meters and the water pressure around him in atmospheres. And so since the depth is 13, 17, 21, the pressure is 2.3, 2.7, 3.1. And I'm trying to figure out the rate of change of the water pressure. Okay. So we've got some x value, we've got some inputs and some outputs at different. So it says when he's at 13 meters, when he's at 13 meters deep from scuba diving, the pressure is 2.3 atmospheres. That's 2.3 times the intensity of our current atmosphere. So it feels really constricted. And then when it's at 21 meters, it feels 3 times as heavy. The air feels 3 times as heavy as it does around us on Earth. So we need to write down what this really means. As the depth changes, the pressure changes. In other words, as we change in our input of depth, we have a different pressure that's output. So by changing how much we change in depth, we can figure out how much pressure we have. So input is depth, output is pressure. We figured out how deep we are, and we can use it to figure out how much pressure we have. Okay, so then that means, let's do with inputs and outputs. Inputs are x values. This is x, and outputs are y values. That's y. All right. So let's go and kind of label some points here. Let's say this is value 1. This is value 2. We can call this value 3. And so that would mean this is x1. This is x2. And this is x3. This is y1 and y2 and y3. All right, we're making some progress. So what this means, we can actually just go ahead and write an equation. We can actually put down we can actually figure this out from here. Well, before we even do that, let's actually figure out the question. The question says, what's the rate of change of the water pressure? Now, remember what I said. Rate of change, for all purposes, all we care about, rate of change is the same thing as slope. So we can just kind of cross that out and say, hey, we want to find the slope of the water pressure. Okay. And slope, we know from our handy-dandy equations, is y2 minus y1 over x2 minus x1. All right, so we'll go ahead and plug these values in. We get y2. Well, let's just use these points 1 and 2. Our y2 can be 2.7. Our y1 can be 2.3. Our x2 would be 17. And our x1 would be 13. Okay, so then we kind of just work this out. Let's see, 2.7 minus 2.3 would be 0.4. So this equals 0.4 divided by 17 minus 13 is 4. Yeah. So that would give us 0.4 divided by 4. Let's see, that's kind of difficult to work with. If we wanted to kind of make this a little simpler, we could multiply the top and bottom by a number to get bigger numbers. They kind of are easier to think about. Let's try multiplying the top and bottom by 10 times 10 times 10. That gives us 4 over 40. Okay, so 4 divided by 40. That's, if we were to reduce that fraction, we could divide the top and bottom by 4. Divided by 4. Divided by 4. That gives us, let's see, that gives us 1 and 10. Oh, so 1/10. So 1 divided by 10 is our answer. 1/10. 1/10 atmospheres per meter. So that means what's going on is that his slope is 1/10. That means every single meter of depth that he's getting is getting 1/10 of an atmosphere stronger. So that means if he was to go 10 more meters, 10 more meters down, it would feel an extra atmosphere stronger. Another 10 meters, you'd feel another atmosphere stronger. Really neat stuff. But that's all we have. Again, if you have any questions, if you'd like to look at this more deeply, if you have anything I can help you with, just let me know. I'm always here to help any way that I can. Thanks.